Hello students, our today's topic is gypsum products. So gypsum, it was found in the mines around the city of the Paris. So that is why it is known as plaster of the Paris. So what is gypsum? It is calcium sulfate dihydrate, that is white to yellowish white in color, and it is found in the compact mass. So gypsum, what is gypsum? It is a naturally occurring white powder mineral with chemical name calcium sulfate dihydrate. It is used. The gypsum products that are used in the dentistry are based on calcium sulfate hemihydrate. So their main use are for cast models and for dyes. What is model? It is replica of several teeth and associated soft tissue, or an alternatively to an edentulous arch, whereas the replica of the single tooth is known as a die. Now what are the five types of gypsum? We classify gypsum into five types: type 1, type 2, type 3, type 4, and type 5. The type 1 is the dental plaster, also known as impression. Type 2 is the dental plaster, that is known as model. The type 3 is dental stone, that is known as model. Type 4 is dental stone, high strength and low expansion. And type 5 is dental stone of high strength and high expansion. How do we manufacture the gypsum product? The process of heating gypsum for the manufacture of plaster, it is known as calcination. So what we do for the manufacture of the gypsum product? The mined gypsum is grounded and heated. So when you heat the gypsum, that is calcium sulfate dihydrate, it loses some part of its water of crystallization and it will change into calcium sulfate hemihydrate. On further heating, the remaining water of crystallization is lost. So a soluble anhydride solution, that is hexagonal anhydrate, is formed. Later, on later heating, it will change into orthorhombic anhydrate, that is insoluble anhydrate. So how do you manufacture the dental plaster and the dental stone? The gypsum, it is grounded and heated in an open kettle at a temperature of 110 to 130 degrees Celsius. So this process is a dry calcination that involves the formation of beta type of crystals. So how do these crystals will look like microscopically? They will look like fibrous aggregates of fine crystals with having capillary pores. So they are then grounded to needle-like crystals so that can improve their packing. How do we manufacture the dental stone? The gypsum, it is calcined under the calcined under the steam pressure in an autoclave at 120 to 130 degrees Celsius for 5 to 7 hours. So the product formed here will be much stronger and harder than the beta hemihydrate. So how do the crystals of dental stone look like? They will be in form of rods and prisms. So if the gypsum is calcined if the gypsum is calcined by boiling it in 30-degree calcium chloride solution, the chlorides, they are then washed away or autoclaved in the presence of sodium succinate 0.5%. It will produce the densest of all the three types that can have even a stronger strength. So these These alpha modified stone with high strength will have microscopically appearance of cuboidal in shape. So because of the difference in the crystal size, surface area and degree of lattice perfection, the powder are referred as alpha hemihydrate, that is the term we use for the dental stone, and beta hemihydrate for the plaster of the Paris. Now what is the difference between the alpha hemihydrate and the beta hemihydrate? The alpha hemihydrate, they are formed when the dihydrate it is heated under the steam pressure, whereas the beta hemihydrate, they are formed when the dihydrate it is heated in an open kettle or a kiln. The alpha hemihydrate crystals, they are denser and have a prismatic shape, whereas the beta particles, they have an irregular shape. The hemihydrate particles, when mixed with water, the alpha hemihydrate produces a much stronger and harder dihydrate structure, and beta hemihydrate, they produces a less stronger and harder dihydrate structure, which will require less water, alpha hemihydrate or beta hydrate. The alpha hemihydrate would require less water as compared to the beta hemihydrate. Now this diagram will represents when the dihydrate it is heated in open kettle type 2 model plaster is formed, when it is heated under high pressure steam type 3 dental stone is formed, when we boil under calcium chloride solution type 4 and type 5 that is high strength stone, they are formed. Now coming to the setting reaction of the gypsum product. The reaction between gypsum product and water produces a solid gypsum. So the heat involved in the is the exothermic reaction, that is equivalent to the heat usually used originally for calcination. One thing that you have to remember is the set gypsum never attain 100% conversion unless they are exposed to high humidity for a long time. So there is unreacted hemihydrate remaining in the set solution. Now coming up with the setting reaction, there are three proposed theory of gypsum setting. The one is the colloidal theory, other is hydration theory, and third one it is the dissolution and precipitation theory. So what is colloidal theory? When gypsum is mixed with water, hemihydrate enters into colloidal state through a sol gel mechanism. So in the sol state, the hemihydrate particles, they are hydrated to form dihydrate. So they enter into an active state. So as measured amount of water is consumed, the mass again get converted into the solid gel. Whereas the hydration theory suggests that the rehydrated plaster Paris unite through hydrogen bonding with the sulfate group to form a set material. The widely accepted theory is the dissolution precipitation theory. So this the setting reaction it is explained on the basis of difference in the solubility of the hemihydrate and dihydrate. The hemihydrate it is 4 times more soluble than the dihydrate. So when the hemihydrate it is mixed with water, a suspension is formed that is fluid and workable. The hemihydrate will dissolve until it forms a saturated solution of calcium and sulfate. So this saturated hemihydrate solution it is supersaturated with respect to the solubility of the dihydrate. Precipitation of that will lead to the precipitation of dihydrate. So when the dihydrate will precipitate, the hemihydrate will continue to dissolve. So this process goes on until further no further dihydrate they can precipitate out of solution. So the setting reaction takes place time to complete, and Changes in the mixture begins as soon as hemihydrate and water they are mixed together. So initially what you will see is there is little reaction and no rise in temperature. So this time is the induction period. As the reaction proceeds, the gypsum is formed in the form of needle-like crystals. They are spherulites. What is excess water? The actual amount of water that is necessary, that is needed to mix the calcium sulfate hemihydrate. It is always greater than the amount required for the chemical reaction. That value is 18.61 gram of water per 100 gram of hemihydrate. So this is the excess water. So the excess water, it will not react with the hemihydrate crystal. It is lost by evaporation once the gypsum is set. So this excess water will serve to aid in mixing the powder particles, and it is replaced by the voids. Now what is mixing time? It is the time from the addition of powder to the water until the mixing is completed. You can mix by the mechanical mixing or hand spatulation. What is the working time? It is the time from the start of mixing to point where the consistency is no longer acceptable for product intended purpose. So what is the adequate working time? It is generally a 3-minute time. What is setting time? The time that elapses from the beginning of mixing until the material hardens. It is known as setting time. So what are the tests that are performed for the setting of gypsum product? The three tests that are generally in use. One is the loss of gloves test, second Gilmore test, and Wickett test for setting time. So in the loss of the gloves test, what you will see is the gloves would disappear from the surface of the plaster mix. So it is used to indicate the initial set. Second method is the exothermic reaction. Since as we know that the setting reaction, it is exothermous in nature. So this temperature rise may be used for the measurement of the setting time. The third is the penetration test. Here we use penetrometers like Wickett needle and the Gilmore needle. So the setting time, it is the time elapsing from the start of mix till the needle does not penetrate to the bottom of the plaster. It is known as the setting time. Now what are the factors that affect the setting time? Number one is the manufacturing process, second mixing and spatulation period, water powder ratio, temperature, and the modifiers. Theoretically, there are three mechanisms that can achieve such control. Number one is the solubility of the hemihydrate. What you see is if you increase the solubility of the hemihydrate, so if you increase the solubility of the hemihydrate, the supersaturation of the dihydrate that can occur, that can be achieved faster. So that will accelerate the rate of the dihydrate crystal formation. Second is the number of nuclei of crystallization. The greater the number of nuclei of crystallization, the faster the dihydrate crystal will form and sooner the mass will harden. So and the third is the increasing or decreasing the rate of the crystal growth that will accelerate or retard the setting time. So if the soluble anhydrate it is in excess, the plaster will set faster, and if natural anhydrate is in excess, the plaster will set slower. Finer the hemihydrate particle size, the faster will be the set. as we know that the hemihydrate they dissolve faster and the gypsum nuclei they are more numerous, so that is why the crystallization will be faster. So within limits, next is the mixing and the spatulation. So within the limits, the longer and more rapidly the gypsum products they are mixed, shorter will be the setting time. As we know that the crystal they will be broken up by the spatulation process, so that will result in more nuclei of crystallization. So faster it will set. Other is the water powder ratio. More the water that is used for mixing, there will be fewer nuclei per unit volume. So if the nuclei are fewer, that means the setting time that will be prolonged. Third is the temperature. Other is the temperature. On increasing from room temperature of 20 degrees Celsius to body temperature of 37 degree Celsius, the rate of reaction that would increase slightly. So the setting time it is shortened. If the temperature is raised above 37 degree, the rate of reaction would decrease and fetting time is lengthen. At 100 degrees Celsius, solubility of hemihydrate and dihydrate they are unequal, in which no reaction can occur, and gypsum and the gypsum that will not set. What are accelerators and retarders? If a chemical that is added to decrease the setting time, it is known as accelerator, whereas if it increases the setting time, it is known as retarder. What are accelerators? The example of accelerators, they can be finely powdered gypsum. Another source of gypsum that is slurry water or low concentrations like salt or potassium sulfate and sodium chloride. They could be the accelerator. So they act by making the hemihydrate more soluble. So that will decrease the setting time. Whereas the retarder, the example of retarders, they can be borax, acetate, citrate, like example is ABC, acetate, borate, citrate, tartrate, salts like ferric sulfate, chromic sulfate, aluminium sulfate, they can be retarders. Colloids such as gelatin, agar, coagulated blood, they are effective retarders. The important properties of gypsum they are setting expansion, strength, and hardness. Regardless of the type of gypsum product selected, an expansion of mass that can be noticed during change from hemihydrate to the dihydrate. So this linear expansion may be as low as 0.06 or as high as 0.5%. So what is the mechanism of this setting expansion? As we know that the crystallization of dihydrate, they are they are pictured as a outgrowth of crystals from nuclei of crystallization. So these crystals growing from the nuclei they can intermesh with and obstruct the growth of adjacent crystals. So when the process repeats within thousands of crystals during growth, an outward stress or thrust develops that will produce expansion of the entire mass. So the structure immediately after setting is composed of interlocking crystals which are micropores and pores that containing the excess water required for the mixing. So the setting expansion they can be of two type. One is the normal setting expansion and other is the hygroscopic setting expansion. So the expansion under the normal setting condition that consists of five stages. Stage 1, stage 2, stage 3, stage 4, and stage 5. So the stage 1 consisting of the crystals of dihydrate that begin to form on nuclei, moving to the stage 4 and 5 consisting of crystals becoming intermeshed and entangled. Whereas the hygroscopic setting expansion, it is a physical phenomenon and it is not caused by any chemical reaction. So when the gypsum it is placed under water before the initial set stage, a greater expansion is seen. It occurs due to the hygroscopic expansion. So it is greater in magnitude than the normal setting expansion. So it is used to expand some gypsum bonded investment. So when the expansion begins, what you will see is the externally available water is drawn into pores, forming into setting mass, and this mass will maintain a continuous aqueous phase in which crystals growth take place freely. Whereas under the dry condition, this additional water is not available, and as expansion occurs as aqueous phase in the mix, it is reduced to film over the growing crystals. Now, how can you control this setting expansion? So, number one, a lower water powder ratio and longer mixing time will increase the setting expansions. Accelerators can decrease the setting expansions like potassium sulfate, sodium chloride. Accelerator like potassium sulfate will decrease the setting expansion, whereas sodium chloride and ground gypsum that can increase the setting expansion. Coming to the strength increases rapidly as the material hardens after the initial setting. So what are the factors that affect strength? One is the Number one is the free water content, that is the excess water. So the greater the amount of free water in the set stone, the less will be the strength. What is wet strength? Wet strength is the strength when the excess free water is present in the set gypsum. And what is dry strength? It is the strength of gypsum when the excess free water it is lost due to evaporation. It is 2 or more times greater than the wet strength. So greater the water powder ratio, the greater will be the porosity and lesser is the dry strength of the set material. The material that is mixed at high water powder ratio, it has a diametric tensile strength as high as of the corresponding compressive strength. The compressive strength it is inversely proportional to water powder ratio. Remember the model plaster it has the greatest quantity of excess water, whereas the high strength dental stone that contains the least excess water. The high strength dental stone it is densest and show the highest compressive strength, whereas the model plaster it is most porous and it will show the lowest compressive strength.